Okay, so in this subtopic, we want to look at other network technologies that enable our networks to be secure and efficient. So the first technology we're going to look at, or the first component we're going to look at, is network security. Network security. So let's do this. Okay, so the traditional, or let me not call it the traditional, but really the IP network, and its design in terms of the TCP/IP protocol stack did not provide any security measures or mechanisms for the data. So that was the biggest weakness, because that time security was not a major concern. But as more and more people were connecting to the network and were learning about the computer network, then it was possible to explore certain security gaps on the implementation of these protocols. Now, when we say that the TCP/IP protocol stack does not provide the necessary security mechanism, what we mean, for example, is that it does not enable us to do data source verification. So it does not provide authentication services so that we can know that indeed this data is coming from so and so. It does not provide confidentiality. So we cannot be able to hash data. It actually transmits data in plain text. So we don't have data confidentiality, we don't have data integrity check, and things like non-repudiation. Now, these are some of the vulnerabilities that we have at each layer of the TCP/IP. For example, these are some of the attacks that we can encounter at layer 2. These are some of the attacks that we can encounter in layer 3, at the transport layer, and of course at the other upper layers. So I'm sure you're already aware of most of these attacks. So really, we are supposed to use various technologies to ensure that hardware, software, and data in network systems are not maliciously damaged, modified, and intercepted. And network systems continually provide services. So we are supposed to ensure that. So let's go on and look at some of the ways in which you can achieve this. So we have certain network boundaries that are important, and for you to understand them, you must understand the extranet, the intranet, and the user access, so that you protect against attacks from each of those points. So network boundary security. So a network boundary is located at the intersection point of the controlled network, that is your intranet, and the uncontrolled network, which is the internet, and is the position where inbound and outbound traffic are checked. So here we check the inbound and outbound traffic. Then we have internal network security. In the internal network security, we try to verify, check, and filter passing traffic and take necessary protection measures on the network devices. So we have a security server, for example, within. We also have intranet access security. So this one is used to authenticate users, check their devices, whether they have updated antiviruses, whether the firewall is enabled or disabled, whether they're using outdated applications, and so on and so forth. So users are pre-authenticated at this particular point. So before they are able to access our internal servers, they have to be authenticated and authorized. Then we also have terminal device security. So in our network devices, like the computers and laptops, we'll, for example, create domain names so that people have to log in so that we can identify them at this point, even before we pre-authenticate them again when they want to access either our internet, or whether they want to access the internet from our network or any other component of our internal network. Okay. So routers and switches provide certain security features, and these security features, if configured correctly, then you really do not need a dedicated security hardware. Now, some of the security features that routers and switches provide at layer 3 are this one. So you can configure ACLs, you can configure ARP security, you can configure firewall zones. This is something we did in the previous module. At layer 2 security, you can configure port security, you can configure IP source guard in order to avoid people who might want to forge their IP address, DHCP snooping to avoid, for example, attacks that prevent DHCP users from acquiring a valid IP address, and things like storm control. So those are some of the things you can do, security configurations that you can do in order to improve security in your network. And on the device like a router or a switch, you may need to configure security login so that people need to log in. You may need to configure CPU defense policy just to ensure that your CPU cannot be exhausted by, for example, denial of service attacks. So a single process, for example, cannot be able to consume beyond a certain percentage of the CPU. So every process has a limit. And you can also do protocol packet authentication in your devices, so that when protocols like OSPF or BGP are exchanging packets, then for them to form the neighbor relationship, they have to be authenticated so that no one else can be able to inject false packets within your network. So these are some of the configurations really that you can do in order to prevent attacks for your network. Just a moment. Okay. At the network boundary is the intersection point of your intranet and extranet, or the internet. So at the network boundary, most of the time, we deploy a dedicated security device like the firewall. So the purpose of this is so that we can filter traffic from the external network. And firewalls can also be able to defend against some of the common attacks from external networks. You remember in the last in the previous chapter, in the previous module, we looked at how to configure security zones, for example, so that we have the trust and the server zone, and now we can be able to control which traffic will allowed from trust to untrust, or from a trust to the server zone, and so on and so forth. So the firewall really enables us to filter data based on the quintuple, that is source, destination, address, source, and TCP port numbers, or the protocol type. And you can also be able to filter data based on the sessions. So it can be able to create sessions. The other component that you can also implement at the network boundary is, for example, an IDS or IPS. So IDS is intrusion detection system, while IPS is intrusion prevention system. Now, a firewall might not be able to filter application layer data. It cannot be able to scan, monitor, and filter application layer data. But the specific device that can be able to prevent application layer data attacks are IDS and IPS. Main difference between detection is that the detection acts only on bypass mode. What that means, it's going to detect the attack and generate an alarm, and do a recording of that particular traffic, details about that traffic, so that now the network administrator can take action. But with network prevention systems, they work in what we call inline mode. So they detect and block the attack traffic. So that's the main difference between IDS and IPS. IDS bypass mode, works in bypass mode. IPS prevention acts in inline mode, and therefore can be able to detect and block any attack traffic. Other security systems that can be deployed at the network boundary include the antivirus system, and also you can use VPNs when external users, want to access our intranet in order to improve security. So of course, VPNs again are normally created at the network edge. I think, sorry. Here, this is where you can still be able to deploy both a firewall and an IDS. So at this point, this is where we have deployed an IDS or IPS. So it will be able to do intrusion detection and also to manage internet behavior management. So for example, you can be able to configure which sites are allowed to be accessed by our intranet users. So you do that through an IDS or IPS. Okay. So let's look at the evolution of the firewalls. I think this is something we looked at also in the previous module, so I'm not going to spend a lot of time here. So really, at the very beginning, in fact, firewalls at the very beginning were simply doing access control, working like access control lists. So they were simply doing packet filtering and could not be able, for example, to create sessions in order to filter data faster. But we quickly moved on to UTMs in around 2004, and with UTMs, it's what we call the United Threat Management. It's able not only to filter packets like an SEL, but the reason why we call it United Threat Management is because it can be able to do intrusion detection. It can be able to check for antivirus, URL filtering, application control, mail filtering, and so on and so forth. So really, we combined most of the security issues in the UTM, and right now we are using the next generation firewall, NGFW. So it's able to do management control based on users, application, and contents of that particular packet using deep packet inspections. So really, I need to mention about right now, stateful inspection firewalls are the most used firewalls, and the Huawei USG firewalls actually are the latest design of firewalls, what we call the next generation firewalls. So we're also going to look at a few examples there, but I think I should mention something. In terms of firewalls, we have two major categories. So I mentioned packet filtering, and we also have stateful inspection firewalls. So we have these two. Now, the difference between these two is this. This one simply uses ACLs. Here, what you can see here in 89, uses the ACL technology to filter packet. And it filters packet based on the quintuple. By quintuple, quintuple. By quintuple, we mean destination and source address, destination and TCP address, or port numbers, or the type of packet, or protocol, really. So that is how it works. Now, the main difference with stateful inspection is that with stateful inspection, you can now be able to configure security zones. So like what we did in the previous module. Other than securing, configuring security zones, with stateful inspection, it can be able to establish sessions. By establishing session, we mean this. When we identify a data flow, you know what a data flow is. In packet filtering, every packet has to be matched through the ACL. But with stateful inspection, the first packet comes in, we check, for example, the source and the destination address. Then we match it through the ACL. And therefore we say, if any other packet that has this source and destination address comes in, we don't have to match it against the ACL. We will simply allow it. So that is what we call establishing a session. And that's the main difference between packet filtering firewalls and stateful inspection firewalls. So it's something you should always consider when you're going to, for example, purchase firewalls. But as I mentioned, most of the firewalls nowadays actually use stateful inspection. So let's look at the intranet access security. Normally, what happens is that the user needs to be authenticated before accessing the enterprise intranet. So really, these are the users, and these are the type of users that you can have in your intranet. So you can have remote employees on site, guests, or external unauthorized users. Now, all these people have to be authenticated. They have to be authenticated. So you have to specify the security policies. Now, during authentication, you will have to block anyone who's not authenticated. So they're simply going to be blocked immediately. Otherwise, if they're authenticated, they can move on to the next phase. In the next phase, we are going to check. We are going to check whether you meet some of our security policies in terms of, for example, do you have an updated antivirus? Have you enabled your firewall? Are you using an up-to-date browser or software? So if that happens, if no, then you're not allowed to access, but we can give you a chance so that our software, for example, our server, performs a repair or updates your browser or enables your firewall. Then if it is enabled, then you can be able to now be authorized. Authorized meaning we are now able to determine the scope of what you can access. So what can you be able to access? Are you allowed to access sensitive information? Are you allowed to access core information, or just the general information and resources? Now, once we've allowed you to access that particular resource, we need to do auditing. So we have to keep monitoring you and collecting statistics about everything that you do. So generally, this is the cycle of an intranet access security. So what we just looked at, so these are some of the components that you can deploy. So wireless access, access control, and so on and so forth. So when all these guys want to access the intranet, there's always a pre-authentication domain and post-authentication. So pre-authentication means you are here and we've not authenticated you. So when you come into our server, into our intranet, after you've logged in, we need to take you through the servers. So the authentication server, the patch server, which will update any softwares that you have that are not up to date. And if you're authenticated, we are going to create a session for you so that we monitor you. And now we can allow you, for example, to access that particular server. So that is what happens. You can't just go direct. You need to come here. Then we go to our pre-authentication domain. If you are authenticated, then we can take you to post-authentication domain, and you can be able to access whichever resource that that is needed. So that is what happens for external users, remote users. Then they have to go through the firewall, and even after they've gotten into our network, we can still be able to implement another firewall to do authentication and any checks that are needed. So that is how you can implement intranet access security. These are some of the Huawei firewalls. So the most basic one is USG 63/6500 firewall. It is meant for small and medium-sized enterprises. So it provides integrated security and management. So it provides 4 to 8 gigabit Ethernet high security interfaces. It also supports 2 more slots for 10 gigabit Ethernet interfaces. It provides integrated protection, integrates traditional firewall functions. You can be able to create VPNs, intrusion prevention, and antivirus checks. So this one, it can be able to identify more than 6,000 applications, and it provides high precision access control. So most enterprises, medium-sized and small enterprises, will use that one. Otherwise, for these other ones, they are meant for data centers. for data centers. Okay. So these are the other boundary security products from Huawei. So these are used for either intrusion detection or intrusion prevention. So the NIP 6000, NIP 6000, next generation intrusion prevention system, targeted for enterprises, campus, and also carrier networks. So it can effectively defend against common attacks, including worms, Trojan horses. So these are the application layer attacks that we were talking about. So firewalls are not able to detect this. Worms, Trojan horses, SQL injection, etc. So it can be able to identify multiple applications, including mainstream PPP, online games, and social networks. It extracts from transmission protocols and analyze them. So it's able to extract, open up the packet and analyze them. So it supports flow model and also self-learning. So this is the high end, and we also have other low end devices that are targeted for small enterprises, like the USG 2000 BSR. So when you get time, again, you can go through these products and understand them. But for now, that's the end of this subtopic. We can look at this project case. A volunteer? So select devices to connect the school campus and education network. So really, we're talking about the egress device. And as we've said, for the egress device, the most appropriate to deploy at this point is a firewall. So it depends with the number of users that you're having. So if you have so many users and they'll need concurrent sessions, then you need to deploy a high-end firewall. Otherwise, if there's just a few number of users, then you can deploy a medium end or low-end firewall. The other thing you need to consider at the egress, of course, is whether you need redundancy. So if you need redundancy, then you'll need to provide maybe 2 firewalls. Or if you did just link redundancy, then you need to check your firewall whether it offers all the interfaces that you need in order to achieve the uplink link redundancy. So on a campus network, servers deployed in equipment rooms of some colleges contain sensitive information and require high security. How is the network designed? So for servers that require high security, you might need to use security zones to determine who can be able to access it and who cannot. And you may further need maybe to deploy an intrusion prevention system at that particular point in order to ensure that you prevent any possible application layer attacks from internal users or even remote employees to those servers. So those are some of the considerations that you need to make. Okay. So I think we can quickly go through VPN and then we proceed for the break. So virtual private networks, we've already done several. We've already done several stuff around VPNs, and we know that the main purpose of a VPN is to set up a private data channel over the shared network infrastructure, interconnect interconnect the headquarter and the branch over the internet. So this is the alternative to list lines, which we looked yesterday, whose main disadvantage was the cost. List lines are very expensive, and even though they guarantee bandwidth and reliability, most of the time you're going to underuse that particular bandwidth. So that's why most of the time, then we interconnect the enterprise to the branch, or we allow off-site employees to be able to access our intranet through virtual private networks. Some of the components of a VPN is tunneling. So that simply means we create a tunnel over the public network to interconnect the two ends. Normally, we can do this at layer 2 or at layer 3, depending on the technology that we are using. The other thing that we do when we are creating a VPN is encryption and decryption. It also provides for data authentication, meaning we are able to hash data, and also identity authentication at both ends of the tunnel. We are able to verify that indeed this data is coming from the other end, because the VPN has user passwords for authentication at both ends, and they must match. So some of the advantages of VPN is cost reduction. As I've said, list lines are quite expensive. Flexibility. So as the enterprise continues to grow, it's a little bit easier and not just cheaper for you to create a VPN to a new site, and also offers flexible connection for off-site employees who want to access the intranet. And security. On security, we've seen data authentication, encryption and decryption. So even if someone intercepts that data, they cannot be able to make sense out of it. Data authentication, the data is hashed to ensure data integrity. So the only person who can reverse it is the person on the other end who has a matching key. So that's another component of security, and also identity authentication, which helps to ensure non-repudiation. So you cannot deny that really you're the one that sent that particular data. The main problem with VPN is that you are using the shared public network infrastructure. So we cannot guarantee or control the quality of service. So those are some of the basic things that we need to remember about a virtual private network. Oh, it's over. Oh no, I went back. Okay. Okay. Okay, so application scenarios. Let's begin by looking at classification of VPNs. Now, a VPN might be classified in terms of the layer it's working at. When we do this, then we can have a layer 2 or layer 3 VPN. So, for example, for layer 2 VPNs, we normally create, there's what we call L2TP, layer 2 tunneling protocol, to create layer 2 VPNs. For layer 3 VPNs, we normally use GRE, which I think is the technology that we've used so far. L2TP, I think, is on HCIE. Then other than the working layer, we can also classify VPNs depending on the implementation technology that has been used. So one of the most common VPN is what we call a IP security VPN. We also have another one called an SSL VPN, and we've also configured an MPLS VPN. So IPSec, SSL, and MPLS VPN. The other classification of VPNs is based on the application scenario and connection requirement. Now, here we have what we call an access VPN and a site-to-site VPN. Okay, so let's look at this scenario here. Now, you have the headquarters here. This is the headquarters. And now you have a branch in another town or city. You also have partners who you want to allow to be able to access your intranet. You have remote offices, off-site employees, and even when employees are at their home or traveling to other cities or countries, you still want them to be able to use or access your intranet. They are doing this over the internet. Now, the two most widely used types of VPNs is what we call the access VPN, and this is in regard to the application scenario and connection requirement. So what is this for, access VPN? So here we use access VPNs when clients don't have a fixed IP address. So for example, remote offices and employees who are traveling. So they don't have a fixed IP address. They are going to be given an IP address depending on the service provider that they are connecting with. So this mode is preferred for mobile personnel. On the other hand, we create site-to-site VPNs in order to connect two disparate networks. So for example, when we want to connect the enterprise to the branch, the headquarter to the branch, then we need to use a site-to-site VPN. So here, the access points are fixed because we know this end and we know this end. So they all have a fixed IP address, which that particular VPN is based on. And normally, this is used to replace the leased lines, so that instead of leasing an expensive line, then you can be able to create a VPN over the public network, which is one of the main advantages, again, of virtual private networks. So access VPN, an access VPN most of the time is actually created using an SSL VPN. And then an SSL VPN really is a type of VPN that is application based, and actually most browsers are able to support it. On the other hand, for site-to-site VPNs, normally we use an IP security VPN to implement site-to-site VPNs. We're also going to see an application scenario for MPLS VPN just in a moment. So I hope that is clear. Okay, so IP security VPN features. This is something we looked at extensively at HCI level. So again, this is used for access, normally used for site-to-site VPN connections, where you want to connect a branch to the enterprise headquarters. And we know that IP security provides what you call the authentication header and the encapsulating security payload in order to offer or guarantee confidentiality, integrity, authenticity, and anti-replay attacks. So data confidentiality, integrity, and authenticity. So normally, for for uh, 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 for hashing and to exchange the keys that are used, we normally use the Internet Key Exchange for that. So IPSec VPN working mode. So it provides multiple working modes, including transport. We know the difference between the transport and the tunneling mode, where one of them is able to guarantee what we call source and destination confidentiality, while the other is not able to guarantee that. So those are the two modes that you can use while creating IPsec VPN. I urge you to relook into HCIA to find out more about those two. So IPsec can be used with other tunneling technologies. Normally, it is able to create the tunnel between two independent network nodes. And sometimes you can also install a software on a PC in order to be able to set up other than configuring an IPsec VPN on routers or firewalls. You can also create an IPsec VPN via PC to a firewall, for example, or PC to PC, but you need a software to do that. So as I've mentioned severally, this is applicable to the site-to-site VPN. Then we have the SSL VPN. So SSL is Secure Socket Layer, is an acronym for Secure Socket Layer, if I'm not wrong. And it's an application layer protocol that is used to provide security, data security for application layer data. Now, generally, this is normally used by remote users to connect to the enterprise headquarters over the internet. So it uses SSL. Most of the time, the user is simply going to use a standard browser like Internet Explorer, Google Chrome. So you really don't require a client software. So it runs at the application layer, and it does not require any NATing, and it actually provides simplified operational management. So by default, SSL VPN supports limited applications. That is what you can be able to access in the enterprise networks. So more devices at the application and network layer can be connected to the SSL VPN after plugins are installed. So after you've installed more plugins in your laptop or computer, then you can be able to achieve more functionalities in terms of what you can access. So normally this applies to access VPNs to enable remote or mobile users to be able to access our intranet via the internet. Then we have the MPLS VPN. We know that the MPLS VPN is based on the MPLS labels. And we know that we can set up MPLS VPNs either manually or using a protocol, which is called LDP. or label distribution protocol. We can also have layer 2 or layer 3 MPLS VPNs. Now, VPN implementation is normally done at the carrier network. And most of the time, the customer is not aware about this kind of VPN. The main purpose of the VPN is to ensure that we have what we call clear traffic paths and guaranteed bandwidths. So normally, VPNs are created within the ISP's network. So between one provider edge and the inbound provider edge and the outbound provider edge. So this is the customer edge and the other customer edge. So for example, this customer edge is at the headquarters, and this one is at the branch. So really, here we can create a VPN to determine how traffic from this particular person is going to pass through within the ISP's network, depending on the bandwidth that they have paid for. Now, MPLS, because it runs within an ISP's network, it does not provide encryption or any authentication functions. However, you can still be able to implement other technologies that can ensure data security for MPLS VPNs. For example, you can actually build IPSec VPNs over MPLS VPNs in order to provide data integrity and authentication. And normally carriers will divide VPNs based on the access ports that they have within their network. So MPLS, it can be a replacement of the leased lines, and it applies to site-to-site VPN also. So you need to contact the local carrier for them to create for you the VPN if you want to connect via an MPLS VPN, the headquarters to the branch. So MPLS VPNs are also meant for site-to-site VPNs. So we also have a number of VPN products by Huawei, like the IPSec VPN. Sorry. This is just an intro here. IPSec VPNs do not require dedicated devices and is supported by common routers and firewalls. So all the three types are actually IPSec VPN, MPLS VPN. You can create them on routers or firewalls. Note the number of connections and purchase the required license. So you need to configure IPSec VPN client software that runs on a PC when deploying the Access VPN. So anytime you have remote users, you might need to install a client software. For example, just a normal browser if it offers SSL VPN, in order to ensure that they can be able to use Access VPN. But otherwise, I think these are some of the devices that can be able to support. For example, this one supports a maximum of 100,000 concurrent users that are using, that are connecting to your intranet via mobile phones or laptops or desktop computers. So this one supports SSL VPN, IPSec VPN, GRE, and L2TP, layer 2 tunneling protocol. So it also supports web proxy, network extension, file sharing, and port forwarding. So you can Google more about that particular SSL VPN product. Okay. So for MPLS VPN, there's no requirement for client devices. and common network devices such as routers and switches can be able to implement MPLS VPN. For L2TP and GRE VPNs, again, common routers and advanced switches support this functionality. So let's look at this project case before we proceed to a short break. Any volunteer to read for us this project case? Well, let me say this. For this project case, please have a look at it and go through the notes to get a deeper understanding of how it can be sorted out. Asanteni sana.